Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, today we choose a few questions from the collection of tutorial, and we're going to discuss in this video. Okay, so I do hope that all of you ready, and hopefully that this video will help you to spark or begin your tutorial and complete the rest of the questions after this. Okay. So before we continue, I do hope again that all of you may support my channel by click to the button of subscribe, like, share, and bell notification. Okay, without wasting so much time, let's continue. Okay, so please refer to your tutorial book. Okay, these are few questions that I select. Okay, I'm not going to discuss all of them. For example, for this question number 3. Okay, so might be I'm going to choose question B, okay, and 5A. So the rest of 8, 13, and 17 we will complete and discuss all one by one. Okay. So the first question, I chose A just now. Okay, so find the domain and range for each of the following and sketch the graph. Okay, class, when you talk about the domain, okay, domain and range. So keep in your mind that domain is all about the values of x. Okay, domain is all about x. Okay, the value of x that can be used or substitute into the function and make the function define. And the range of f is all about y. Okay, the y, the value of y that being mapped when we substitute the function of x into the when we substitute the function, the value of x into the function of f, and map to the value of y. So that y is the range of the function. Okay, so first, fx equal to x squared minus 5, and given the x less than or equal to 0. Okay, so we might think that this graph of x squared minus 5, okay, will be something like this. Okay, and then the graph, because the coefficient of x squared equal to 1, okay, 1 here, a equal to 1, which is greater than 0, and the graph will be something like this. Okay, the only thing is, are we going to look at all this? Sometimes we need, maybe sometimes not. Okay, so because the question wants us to find the domain and range, class, when they give you something here, okay, the general value of x that can be used into this function of x squared minus 5, so that the function defined is all values of x from negative to positive infinity. Meaning, okay, let's say this is 0, and the value of x to negative infinity and positive infinity, any value of x, we may substitute into this function and makes the function defined. So that is all the domain of x, or that's all the domain for this function of f. Okay, meaning all values of x can be used. Now they limit the domain from the wide of what we call value of x from negative to positive, and now they limit the domain, okay, for x less than or equal to 0. Automatically this is the domain of the function. So we have found the first one here. The domain of f is negative infinity until 0. Okay, now what about range? Okay, the graph, we call the graph of x squared minus 5. Okay, for fx equal to x minus 0 squared minus 5. Okay, so means that when x equal to 0, y equal to negative 5, this is the minimum point, and at the same time is part of that we call the symmetrical of the graph. So let's say this is negative 5, so the graph will be something like this. Okay, it's not very smooth, but it's okay then. So this is fx equal to x squared minus 5. By the way, let's get back to that we call the range of this. the domain of this function, x less than or equal to 0. This is where x equal to 0. So, for x less than 0, is the direction to the right or left? Yes, to the left. So, all values of x, 0, -1, -2, -3, and so on. This is the domain for this function, for this question here. Okay, so it means that, okay, less than or equal, meaning it include with 0. Okay, there you go. So, what's next? We erase this part. Then this is the graph. Okay, sorry. Okay, there you go. This is the graph of fx equal to x squared minus 5 for x less than or equal to 0. Now, value of x is domain. Now, let's find out the graph with the we call minimum value of y, which is -5. The minimum, the lowest value of y is -5. And then the rest of it, it mapped to the y-axis, okay, which is all value of y from -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. Okay, so it means that the range or the value of y that we mapped from this graph for this function reads out here. So then, I rewrite here again. The domain of this function is from -infinity until 0, and the range of f equal to from -5 to +infinity. That's it. Okay, I'm sorry. -5 to +infinity. Okay. Next question. Sketch the graph of y equal to fx, find the domain and range of this function. Okay, I choose A. So for this question here, fx equal to x minus 5 for x greater than or equal to 0 and x squared for x less than 0. Okay, so now let's make a line of y-axis and x. Okay, so class, look at these two. Okay, this one and this one. Okay, so make it number line 0 here for x greater than or equal to 0. And another one here is x less than 0. So for this domain of x greater than or equal is for the function of x minus 5. And x less than 0 is for x squared. Okay, meaning we divide the domain or value of x into two parts. One is for another function and another one is for another function. Okay, let's sketch the in general for, let's say, f1x equal to x minus 5. Okay, we sketch in general without limiting the domain first. Okay, so just imagine that this is also considered as a y equal to x minus 5. When x equal to 0, then y equal to, when x equal to 0, y equal to -5. Okay, and then when y equal to 0 means that x minus 5, fx or y equal to x minus 5, make it equal to 0, then x equal to 5. Okay, so then the first coordinate, which is 0 and -5, 0 and -5, another coordinate is 5 and 0. Where's the coordinate of 0 and -5? Yes, down here. -5 and 5, 0 here. So then, make a straight line here Oh, sorry. It seems that I need to use a ruler to make it what we call nice. Okay, I'll try. Okay, like something like this. I'm not using a ruler for this one. Okay, so this is the graph of x minus 5 in general. Because all values of x can be used, we substitute, then it makes the function defined. Okay, now the thing is, let's get back to the question. Original question here is for x greater than or equal to 0. This is where x equal to 0 and x greater than or equal to where the value of x from 0 to positive infinity. Meaning, yes, any recall graph of this function which is for less than 0 here, what I mean that this is part here, we are going to delete it. Okay. Oh no, sorry. Okay, first we get back to the question here for x greater than or equal to 0, which means that from here, there you go. So then, that's it. So the first graph, the first graph of this one here, oh man, I forgot to change this to a pen. Okay. So then, from -5 to 5, there you go. Okay, so this is a graph for x minus 5, x greater than or equal to 0. And now, the second function. The second function, f2, oh man. X squared. Okay, the graph for the function of x squared is a curve okay, something like this. And now y equal to x squared. Yes, x squared intersect at the point of 0, 0 here, origin point, and this is y equal to x squared. And this valid for x less than 0. This is x equal to 0 and less than 0, all the values of x on the left side. Okay, so it means that here, you begin from here. There you go. So now, we are going to delete this, clear this. So, let's bring this here. That's it. Okay, we complete, or we call sketch the graph for the question of A. This is what we call piecewise function. Okay, piece by piece. So the first one here, x minus 5, linear, straight line for x greater than or equal to 0. This one here, and x squared for x less than 0 here. Okay, now, what is the domain of this function? And the range. Which I think that the domain is all values of x, right? Look at this. Is there any value of x that makes the function undefined? Or any value of x that we are not using, do not use at all? No, we use all values of x, right? So then, the domain of this function is all real numbers. Or you may also write this as a negative to positive infinity. Any of this, because when we call it's actually the same actually. It's just how we write it in a different definition. Okay, what is the range of f? Range of f, if we point this graph to the y-axis, okay, we point this graph refer to the y-axis, and we found that all values of y being mapped from this function, okay, from this graph, until x equal to -5, which means that the least value of, or the minimum of least value of this y, of y is -5. So then it is from -5 to positive infinity. That's it. Get it? Okay. Now, okay, so given a function of fx, gx, and hx, so this is all about a composite function. Find kx, find the function of kx, where kx equal to fgx. So, question A, kx equal to fgx. So, let's find out which one is a function of g. G is 3 minus 2x. Okay, now listen carefully. How's the process of composite between two functions? Okay, example here, g and fx here, fgx. So first we write down the function of gx here, 3 minus 2x, and we are going to substitute the whole function of this 3 minus 2x into an x of the function f. Substitute the function of g into an x of the function f. That's it. So, a function of fx, 2x minus 1. So, just imagine that we make a space for x here, 2x minus 1. So then, this is 3 minus 2x, okay. So 2 times 3 equal to 6, 2 times -2, minus 4x minus 1. So then -4x, 6 minus 1 equal to 5. Okay. Find kx. Just now, we have found that the function of kx, which is kx, is a composite, a combination between fgx here. So we're going to use this one into this function of h. So question B, h kx, okay, I'm sorry then. Okay, h kx. Okay, first of all, write down the function of kx. Kx, it is -4x plus 5. Now, substitute the whole function of this into an x of the function h. This one here. So, it is 1 over 4, 5 minus, okay, 1 over 4, 5 minus, now x, substitute with this one here, -4x plus 5. Okay, so 1 over 4, 5, negative times negative, positive 4x, negative times positive 5, minus 5. 5 minus 5 equal to 0. Then 1 over 4 times 4x. So 4 divided by 4 equal to an x. There you go. Okay, so the next question is, what is the relationship between the function of h and k? Okay, can you guess? Yes. Look at the result of composite function of h kx. It is x, right? Okay. When we call combination or composite between two functions, and it gives a result what we call equal to an x. Okay. Composite between two functions, and it gives what we call the final result equal to an x. Our conclusion is the function of, Sorry, there's a problem there. Okay. So then we come up with the conclusion that function of kx is an inverse to the function of hx. Okay, again, when two functions, because we composite or combine two functions together, and it gives a result of equal to an x, so we come up with a conclusion that one of these functions, kx or hx, either one, okay, kx is an inverse to the function of hx. You get it? Okay, good. Next question. Okay, the function f and g are defined as follows here. Okay, state the domain and range of the function f and g. Okay, so then here, for function of fx equal to x squared plus 1, okay, this is quadratic, am I right? Okay, and then gx equal to square root of x minus 1. Okay, so generally, because it's not stated that the domain of this function or the value of x from 0 to positive or 0 to negative or from one point to another point here, we just assume that this is, okay, x squared plus 1, x 0 and then 1 here. The graph will be something like this. Okay, this is intersection where the y equal to 1. Okay, what about this one here now? Okay, for the question, for the function of, for the square root function, square root of x minus 1 is defined. Okay, function because square root function, okay, square root function of gx equal to square root of x minus 1 is defined. Okay, square root of x minus 1 is defined if x minus 1 is greater than or equal to 0. So then x greater than or equal to 1. Class, once you get this, automatically it tells us that the domain of g function equal to from 1 to positive infinity. Automatically, this is the domain of the function. Okay, and then for the graph of square root function, okay, when x equal to 1, 1 minus 1 equal, okay, x minus equal to 1 here. 1 minus 1 equal to 0. Square root of 0 equal to 0. So when x equal to 1, y equal to 0 here. And generally, the graph of square root function is something like this. Okay, sorry. Okay, that will be something like this. So now, a range of this function, the range of this function, range of g equal to, okay, from point here, let's point to the y, which is 0 here. Okay, all values of x is positive. So it means that the domain is, range is 0 to positive infinity. Okay, so class, for this one, since that the question did not mention about the we call the value of x for this, I assume, okay, I assume that the domain of this function of x squared plus 1 in general is all real numbers, and then the range of f is 1 to positive infinity. I'll take it general according to the question, unless it's stated here x, okay, greater than or equal to 1. But there's no because it's not stated here, right? Okay, we assume that is general. State the domain and range of f and g. Find fgf, gf, and fgf. Okay, so question B, fg, fgx. okay, gx equal to square root of x minus 1. And substitute this function into an x of the function f. So it is square root of x minus 1 square plus 1. Okay, square and square root, so get x minus 1 plus 1 equal to an x. Okay, and then gfx. So fx equal to x squared plus 1. And substitute the function of f into an x of the function g. Square root of x squared plus 1 minus 1. Okay, so 1 minus 1, and then square root with a square, then x. Okay, and this one here, fgx, fgfx. Okay, gfx, we have found it earlier. gfx here equal to an x. Okay, so gfx, we have found it earlier, which is an x here, so x. Then it is x squared plus 1. Sketch the graph of f and g on the same axis. Okay, class, which I think that for this one here, okay, for this question, normally they should come up with this one here. Fx equal to x squared plus 1, and the domain or value of x is x greater than or equal to 1. Because there's a relation in this question, there's a relation between this and this. So it cannot be something like this here. Compare this one with this function of square root function. So actually that, supposedly somewhere around here. Okay, I change this one 0 to positive infinity. Okay, class, I explained to you here just to show you normally there should be we call extra instruction here, okay, extra question here, because we are going to compare this graph with this graph. Okay, so never mind. Next time might be, hopefully that we come up with a complete question here. Sketch the graph of f and g on the same axis, this one and this one. Okay, sorry for what. Okay. Okay, we make a line of y equal to an x. Okay, this line of y equal to an x is just like a reflective mirror, meaning that if you stand here and you're facing a mirror in front of you and you saw the image, okay, in front of you, opposite of you, the distance from you yourself, your object, to the mirror equal to the distance of mirror with the image. You just imagine it. Okay, so now the graph of this one, okay, the graph will be something like this, and then here 1. Okay, that's it. State the domain of f such that f is the inverse of g. Okay, class. Okay, now I know. I put this too early. Because this we call the question of this is here. Question of B. State the domain of f such that f inverse of g. So the domain of f, it is 0 to positive infinity. Okay, yes. This part is actually here question of D. I'm sorry. Okay, explain to you all too early. not according to the question. But this is it. Okay. Now, the function of fx equal to natural log of 2x minus 1. Okay, there's a relation between exponential, okay, and log. Okay, so there's a relation between these two. Not equal, but then there's a relation that we call the arrow of between exponential and log. Okay, there's a relation between these two. Show that f is a one-to-one function. Okay, f x1 equal to f x2. Okay, using algebraic method, natural log of 2x1 minus 1 equal to natural log of 2x2 minus 1. Okay, and then we cancel between these two. Okay, cancelling with, make this one, these two as an exponent. We call index to the exponent to the Euler's constant of e. So then canceling between these two. So then we get 2x1 minus 1 equal to 2x2 minus 2. Okay, please find and we call extra notes about this. Okay, ln left and right, natural log left and right, and we eliminate this by, we call, make the whole function of ln 2x minus 1 as an index power of the constant of e. Okay, and then we cancel between the natural log, log to the base of e, with this e here, then we get the function of 2x minus 1 here. So then, okay, so plus 1 here and plus 1, clear. So you get 2x1 equal to 2x2, divide by 2 left and right, then you get x1 equal to x2. So fx is a one-to-one function. Clear. Find the inverse of function of fx. Okay. To find the inverse of function, let's change this term fx into y. Okay, let fx, make it as a y here. So y equal to natural log of 2x minus 1. Okay, just like the process of this, we make this one as an e power of y equal to e power of natural log of 2x minus 1. Okay, so then it is 2x minus 1 equal to e to the power of y. Then 2x equal to negative 1, bring to the side, become positive, so we got e power of y plus 1. And x equal to 1 over 2 e power of y plus 1. So f inverse of x equal to 1 over 2 e to the power of x plus 1. Okay. Find the domain and range of the function f and its inverse. Okay. Question C. Find the domain. Okay. Find the domain and the range of the function f and its inverse. Okay. Domain of f is also equal to the range of f inverse and range of f. Okay, I make the, we call it with the symbol of equal then. Okay, domain of f is a range of f inverse, and range of f is a domain of f inverse. So now, what is the domain of f? Okay, ln 2x minus 1. Fx equal to natural log of 2x minus 1. Okay. 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 So class, as we know that for the log function, okay, for a log function, okay, log x, okay, so when x, okay, log 1, x equal to 1, then y equal to 0, and log 0, when x equal to 0, and the whole function is undefined. Okay, remember this. Now, how are we going to implement this into this question here? Sorry. Okay. Sorry for one. Okay, I make a short notes here. Log x, okay, y equal to log x. As we know that for log 1, then the whole function equal to 0, and log 0, the whole function is undefined. Okay, so now let's get back to the question here. So f x equal to natural log of 2 minus 1. Okay, look at this one again. Log y equal to log x. Fx or y equal to ln 2x minus 1. Okay, first we need to find the vertical asymptote. Vertical asymptote is a line where the graph will move, approaching, get close to the graph, but it won't touch or intersect at all. Okay, so now but this one here, log 1 equal to 0, meaning when x, okay, x 1 here, log 1, log x, log 1, then x equal to 1, and log 1 equal to 0, y equal to 0. Okay, before this, log 1 equal to 0. Why? Let's say this is a base of a here, because a to the power of 0 equal to 1. You still remember that? Yes, thank you. Okay, so now let x equal to 1, and then log 1 equal to 0 here. So this is it, 1 and 0. This is the intersection point. Okay, the thing is, this is not the value of x for this one here. Okay, so now to make this 2x minus 1, 2x minus 1, let's make it equal to 1 here. Make it equal to 1. So then 2x equal to negative 1, bring out here become positive. So 1 plus 1 equal to 2, then x equal to 1. Again, 2 times 1 equal to 1. 2 times 1 equal to 1, and 2 times 1 equal to 2, and 2 minus 1 equal to 1. Ln or natural log of 1 equal to 0. So x equal to 1. So what is the value of x here now? X equal to 1 and y equal to 0. Here, 1. Okay, and then let's make this one 2x minus 1. 2x minus 1, make it equal to 0, because we like to find the vertical asymptote or straight line here. Make it equal to 0. Okay, so 2x equal to, bring it here, become positive 1, then x equal to 1 over 2. Okay, let's try again. Okay, x equal to half, 2 times minus 1. Okay, let's say I substitute x equal to half, 1 over 2 here, and also 1 over 2. Okay, 2 times half equal to 1. 1 minus 1 equal to 0. So, natural log of 0, undefined. Okay, when x equal to half and the whole function is undefined, so this is where that we call the vertical asymptote. Okay, so now class log, natural log here is also log of 2x minus 1 to the base of e, where e is greater than 1, meaning the graph will be something like this. There you go. And then sketch the graph of f and f inverse on the same coordinate axis. Okay, find the domain and range. So now, okay, I'm sorry, I need to clear this from time to time because we have a limited space. So what is domain of this function now? The domain of f equal to from half to positive infinity. And the range of f equal to, yes, all values of y, all real numbers. So now sketch the graph of f and its inverse on the same axis. Okay, for this one here now, I show you, recall how we sketch the graph of f and its inverse on the same axis. Okay, make a line mirror, okay, reflective mirror for this graph. Let this y equal to nx. So the graph of this will be something like this. Okay, 1 over 2. Okay, and then 1 here. There you go. So it's also happened here 1 and then half. So that there you go. This is the function of f and this is f inverse. Okay, so class, because this is a this is recording to all of you, so I do hope that it helps you. Okay, you may watch whenever you are free. Okay, you may push the play button, stop, rewind, forward, pause, and everything, and all those buttons, okay, needed for you to recall, repeat, and make your own revision and continue with your tutorial. So that's all for me for today. Till we meet again. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.